Now design a Turing machine to accept a language L is equal to a power n b power n such that n greater than or equal to 1. Now we are going to design a Turing machine that is having a path from the initial state to the final state for all possible strings of this language. What are the possible strings of this language? A, B, if n is going to take value 1, A, B, B. So it will be having equal number of A's and equal number of B's, and all A's should precede all B's. Now we have to make sure for every A there is one matching B. Let me take an example and explain this. Let me take a string A, B, B belonging to this language. A, B, B. Now what logic we are going to use? We know that in Turing machine we have a data structure that is an input tape and a header, a powerful header which is capable of moving towards the right or left, or it can remain in the same state. It can rewrite any symbols in the tape, and whenever nothing is there it will be referred as blank. Now we know all these things earlier. Now here what logic we are going to use is, if there is a, for this A we need to find a matching B. So for this A we'll convert that into X and we'll cross all the in between A's and we'll move to the first B which is coming next to A, and we'll try to convert that A to Y. So by doing so, we have identified for one A we have one B. Now we have to repeat the same process for all the A's. Now we have to, once this is over, we need to trace back this header to the starting position. So what is the starting position? Now X is the starting position. Now we have to trace back from this point till Y by moving the pointer one step left. And every time we should not do anything, just we have to move on till the starting point. Now once this point has come, we know that this is a visited A. Now we will move on to the next A. Now we have to traverse to find the pairing B, which is this B. Now in between there can be any number of A's, because if the string length is more than 2, there is a possibility to have in between A's also. All those A's we have to traverse, and all visited B, which is now Y. All those also we need to travel, and we need to arrive at this point. And now before traversing, we need to convert this into X, stating that it is a visited A. For this A, we are going to find a pairing B at the end, after all A's and visited B's, that is Y. So at this point of time you will have XX, Y, and this B will be converted to Y. Now again we are here. We are not sure that there are only 2 A's in the list. So we'll again trace back and come to this position, that is the visited X. And once this X is visited and the next symbol, if not A, if Y is coming, it means that it is a visited B. Now once this B is visited, we need to traverse till the end. Till the end means, what I mean is till the blank. Only then we can confirm that all the B's, or we need to confirm that all the B's are visited, because once we have, after this X, if Y is coming, it means that all A's are visited. In that case, all B's should be visited. Only then the count A power n, B power n will be true. So we have to confirm that all the B's are visited by traversing to the left, by having a move only for this Y, which means that the B is visited. Then when blank is coming, we will stop. This is the logic we are going to follow. I'll try to give a flowchart for how this Turing machine is going to work. First we will check if, let me name this header as H. If this H is going to point to A, if yes is the condition, then what we need to do? Replace A by X. Now this is what the first step we have to do. We have to replace, because this A is now visited. We are marking this A as visited. For this A, we need to find a matching B. In between, there is a possibility for having more number of A's. So move all A's. And there can be a possibility to have visited B's also. So you move all A's and visited B's, and after that if you find any B, you replace that B by Y. Okay, once you replace that B by Y, the next step is we need to traverse backwards and check for the next A. Now if this continues for all A's, we will be trying to find one B and we'll try to pair up. If this fails, in that case, if your H is not equal to A, the only condition it is, it should be Y. It should be Y. In that case, you have to have a possibility to move all Y's. You move all Y's, and if blank comes, if your H is equal to blank, then accept the string. Accept the string. This is what is the logic we are going to follow to design this Turing machine. Now, let me give the transition diagram for this Turing machine. So, I am going to give the transition diagram for this Turing machine. Once you understand the exact logic of how we are going to check the number of A's and B's, then this transition diagram will be clear. Don't bother about the states. When there is a change in the input tape, we are going to make a state transfer. Now initially let us assume we are in Q0. What is the possibility of a string symbol first to come as only A? That A we will replace with X and move towards right. In between there can be any number of A's. You replace that with A and move towards right. And after that a B can come. You replace that with B and move towards left, because for this A we have found one match B. Now while moving towards the left, there is a possibility of A coming again. Okay, we have to move towards the left hand side. Move towards the left. Now let this state be Q1, this state be Q2. Now once we move towards the left hand side, we will arrive at a point where, see, we have converted this X. In between A's we replaced with A and moving towards the right. B comes, we have replaced that with Y and we are trying to move towards the left. In that case, all A we have replaced with A and come to this point. That is the starting point where we have started. Now what will come? X will come. If X comes, it means that is the visited A. So you replace that with A and move towards the right to fetch the next A. So while fetching the next A, you replace that with X. So that's what we have done it here. You have replaced that with X and you are moving towards the right hand side. So in between, here we have considered only two A's. So there is no A, but there is a possibility to have visited B. So here we should include, if visited B is coming, you replace that with B and move towards right. And then you convert this B to Y, that is a new B, that is unvisited, to Y, and move towards the left hand side. While moving towards the left hand side also, there is a possibility to traverse all the visited B's. So now once we come here, when X comes, it means that, so while returning back, we will arrive at this X now. Now 2X converted, 2Y converted. When X is coming, instead of A, when Y is coming, it means that we have traversed all the A's. So for every A, we have found a matching B. Now we need to confirm that there is no more B exist at the end. So if Y comes, replace that with Y, move towards the right, and you need to give a transition only for Y. If Y comes, replace that with Y, move towards right. Okay, so this is Q3. Now after that, if blank comes, you replace that with blank and halt. That is going to be our accepting state, Q4. That's going to be our accepting state. Now this comes the transition. Here comes the transition diagram. What about the transition table? So you have delta transition. You will be considering Q, tape symbols. There will be a change in the state and tape symbol with left or right operation. Okay, that is what. No. So this is transition. No need to, you see the diagram, you will have, it will be very clear what are the transitions for this particular Turing machine. Now we need to give the transition table. Now you give the states Q0, Q1, Q2, Q3 and Q4. What are the possible inputs? So A can be possible input, B can be possible input, X, Y and blank. What are the possible tape symbols we need to include? So these are the possible tape symbols that will be in columns. Okay, now from Q0, if A comes, where it is going? It is moving to Q1 with a change in the tape symbol to Y and with right move. So for B there is no transition. For X also there is no transition. For Y it is moving to Q3 with Y and R. Okay, for blank there is no transition. Now from Q1 you have a transition for A, B and Y. So from Q1, A it is going to Q1 replacing with A and moving towards right. For B it is moving to Q2 replacing with Y moving towards left. For Y it is remaining in the same state replacing with Y moving towards right. For blank there is no transition. For Q2 you have three transition A, X and Y. So for Q2, for A it remains in the same state, A replaced with A and moving towards the left. And for B there is no transition. For Y it is going to Q0 replacing with, for X it is going to Q0 replacing with X and moving towards right. For Y it is replacing with, it is moving to state Q2 replacing Y with Y and moving towards left. There is no transition for blank. Okay. Now Q3. Q3 it's not having any transition for A, B and X, but it's having transition to Q3 replacing Y with Y and moving towards right hand side. And for blank, it is moving to accepting state replacing blank with blank and halt. For final state there is no transition. Now this is going to be our transition diagram. Okay, I think I made myself clear in explaining how to design a Turing machine for the language L is equal to A power n, B power n.